Today we are going to do our next topic, which is hemerythrin. Both hemoglobin and hemerythrin have iron as the oxygen carrying metal. Despite the appearance of heme in the name hemerythrin, it does not contain a heme group. Hemerythrin does not contain a heme group. The comparison of properties of oxygen carrying proteins are oxygen state of metal in deoxyprotein, metal, metal and O2, uh, coordination of Fe, number of subunits, color oxygenated and color deoxygenated in hemoglobin, hemerythrin and hemocyanin respectively. So here 221 FeFeCu FeO2 2FeO2 2CuO2. Porphyrin ring, protein side chains, 4, 8 and many. Red, violet pink, blue, red purple, colorless and colorless. Subunit formation. The hemerythrin molecule consists of 8 subunits and can be dissociated into monomers by a variety of means. Protein ligand to iron. Since hemerythrin does not contain a porphyrin moiety, the iron must to be coordinated in part to side chains provided by the protein matrix. This is the structure which shows primary sequence of hemerythrin. Structure of active site is the properties that the structure of hemerythrin account for are low magnetic susceptibility for oxy and met hemerythrin and dimagnetism in the ground state at low temperature. Non-equivalence of the iron environment in oxy hemerythrin and the equivalence of iron environment in met and deoxyhemerythrin respectively, indicated by Mossberg spectroscopy. The absence of Bohr's effect or proton release upon oxygenation, the optical absorption and circular dichroic spectra. Now here it is met-hemerythrin. Garbett and co-workers explained 1:2 ligand to iron stoichiometry of hemerythrin complexes with azide and with thiocyanate and similarity between iron environment indicated by the Mossberg spectra in terms of the symmetrical double double bridged structure. The complexes of met hemerythrin have similar circular dichroic spectra. These are the structures. And oxyhemerythrin. The Mossberg spectrum of oxyhemerythrin is different from deoxyhemerythrin and consists of two doublets. This indicates that both iron atoms are affected by the binding of the oxygen molecule. However, the bonding of two irons to the oxygen molecule is different. The difference between the quadruple splitting in the two iron atoms may due to a difference in the strength of their bonds to the peroxide ion. This difference arises from hydrogen bonding to the protein. Finally, in the oxyhemerythrin structure corresponding to structure for methemerythrin, the peroxide ion may be bound to a single iron atom either with the Griffith structure 1 or the Pauling structure 2 functions. The main goal is particularly to understand the function of biological molecules in terms of their structural and electronic properties. In explaining how hemerythrin functions as an oxygen carrier, to account for the stability of the oxyhemerythrin complex with respect to methemerythrin. Hemerythrin is a non-heme dioxygen binding pigment. Hemerythrin contains iron 2 which binds oxygen reversibly, but when oxidized to methemerythrin Fe3+, it does not bind oxygen. There is an octameric form with molecule weight of about 108.000 that transports oxygen in the blood. In the tissue, there are lower molecular weight monomers, dimers, trimers, or tetramers. Hemerythrin consists of 8 subunits very much similar in quaternary structure to myohemerythrin. A major difference between hemoglobin and hemerythrins is in the binding of dioxygen. Each dioxygen binding site contains two iron 2 atoms and the reaction takes place via a redox reaction to iron 3 and peroxide O2-2. Oxyhemerythrin is diamagnetic indication spin coupling of the odd electrons on the two iron atoms. The two iron centers combine with one O2 molecule and oxidize to Fe3 while O2 is reduced to peroxide form. Thus, O2 binding in hemerythrin is a redox reaction. The peroxide ion O2-2 formed in the oxyhemerythrin is not bound irreversible to Fe3. However, it is transferred to required site of Fe3 to return to Fe3 state. Thank you so much for watching.